Hi, this is Budek. I'm now going to demonstrate the power of using the IoT Toolbox with demo software that you may have run on your system, and you want to do a live demo. You want to show how it interfaces to an Android or an Apple phone. The IoT Toolbox software is available at no charge on either the Google Store or the Apple Store, and you download that to your laptop, to your phone, or to a tablet that you have. I'm showing two different form factors. I'm showing the what we call the D6 board for doing the QN9090 Bluetooth low energy device, and also a layout of a smaller board. This board allows you to interface a bunch of connectors, different sensors, including analog sensor that I'll show in another video. This particular form factor is very small, and it has a coin cell battery that plugs in on the bottom. These wires are for a power supply. Those can be clipped off. Right now this is a moisture sensor taking A to D readings, but I can also use it for just bypass these and use the onboard temperature sensor or battery voltage inside the device, and that's what I'll be demonstrating first. Because it's just taking an A to D reading, there's also other form factors of temperature sensors. Maybe you want one to clip onto a pipe or clip onto a battery connector. All of those I can hook up with two wires to this device and be able to use it and show you that it does a graphing function as well. So getting started, I've got the software running. It auto starts. Some of the demo software need a button to push to start it, but obviously if I'm building a sensor board, I don't want a button, so I just rewrote the software to be auto starting. The graphing function will be heart rate. So if we look at here, we have a bunch of different functions we could run. Temperature won't give you a graph, and so what I've done is modified the heart rate example. And the first thing you'll notice that, again, it's set to auto advertise. I've changed the name to be temperature sensor node, and it's showing me my RF power level. When I go ahead and make a connection, I'm just going to use 1 megabit legacy. It auto scales, and I've got to figure out how to make that scaling change a little bit because it's going to 0 to 200. I'm measuring the actual onboard die temperature, which is 0 to really 25 degrees, 26 degrees Celsius is the room temperature. So I could change that scaling, but if it were to go higher than 200, it would auto scale and bring those numbers down. But right now it defaults to 0 to 200. It's taking a reading every second. The battery is the reported voltage battery of the sensor. It reports that every 10 seconds. You'll see when I plug the coin cell in, it'll be a lower value. And again, it's taking a temperature sensor every second. And what I'll do now is, and that reporting interval can be changed. I'm going to go ahead and turn on a hair dryer onto the unit. We can see that the temperature starts to go up. You got to be careful with the heat gun. It's very easy to reflow the solder of the device. And you can see that was on a cool setting. If I go to a little bit warmer setting, I can get that up a little higher. And again, it's showing beats per minute, but again, it's really the temperature in Celsius degrees, and we'll see that temperature come down. So the next step will be then obviously to hook up remote temperature sensors, hook up a solid state sensor. If it's measuring the onboard die temperature, it takes a while for the dwell, for the heat has to heat up the package, then it has to heat up the die, and then finally has to take a measurement. So there's a lot of lag when it takes those measurements. If it's a remote solid state sensor, it would obviously work a lot faster than that. And we could see that it'll gradually come back down to about 25, 26 degrees Celsius. Any other questions, let me know, and I will fire up this board next and see how that works. Hello, Budek, back here again, and I've loaded up different software onto the development board, or I could use the smaller board as I mentioned before. In this case, I'm going to show you that besides temperature sensing, any kind of sensor that's an analog or digital voltage can be programmed into the device. So in this particular case, I'm going to simulate a sensor using a potentiometer, going to run the same IoT Toolbox application, and with that we're going to run the heart rate sensor. What I've done is I've changed the name, so you can see the name now is NXP pot for potentiometer. I'm going to go ahead and choose the same legacy PHY. And again, it's a heart rate, but it's not really. It's an analog to digital conversion, and it's showing that it is connected. It shows the battery voltage on the bottom. If I come back here and list the information, you can see I've changed it that now it's going to read the potentiometer, which is a different application, and go over here and twist the potentiometer. And I could see that the unit auto scales, so now it went up to 3000 because the maximum was 3600, and it does a graph. It's measuring again every second. That interval can be adjusted, so I'm going to turn the pot a little bit more. You can see the voltage come down, but I get a nice graphical output using the IoT Toolbox. Same software, just using different routines to read a different software routine. Gives me a different output. So again, it shows the power and versatility of using the IoT Toolbox and allowing one device to meet a bunch of sensor applications that you might need with a wide variety of interfacing to Android or Apple. Hi, Robin Budek back again. So now I'm going to demonstrate a different type of sensor. Because I've got the A to D, I can put multiple sensors on. I'm going to use that meander pattern that can be used potentially to find moisture or humidity. I've reflashed the device, so now it's a standalone. The cable is hooking up to the programmer just because I don't want to keep plugging and unplugging it. The jumper needs to be installed when you flash it, but then afterwards when you're executing it, you no longer need that jumper. And so heart rate sensor again, because I want to get graphical output. I've got the potentiometer software loaded in there because as far as all it knows is that I am going to be taking an analog to digital reading, and it'll start up here shortly and tell me, there we go, and now it starts graphing again. The default is 0 to 200, and what I will do now is I have got a cotton swab that's with moisture, and when I start to rub it, you can see it starts to conduct more, so the reading goes up. And that could be an alert. You could run certainly these things in parallel. You could have a temperature sensor, other sensor, maybe a motion sensor, and then now if I wipe off the moisture, my finger had a little bit of moisture on there, so it'll eventually settle down and go back to its normal value. So a wide variety of sensors we can hook up, either homemade ones on a printed circuit board, as I mentioned, maybe some kind of clamp-on devices you put onto your pipe device. As long as you can get the sensor data in here, run multiple ones in parallel, you'll be able to get a sense, get graphical data, be able to store it, and set off an alarm. And now last thing to do will be to reflash this one to be a temperature sensor. As you can see, the moisture is dropping down. And again, the interval changes. Oh, you can see the battery voltage at the bottom. The interval, reporting interval changes. That can be changed. I've got it for 1 second. It's reporting 87%. That is the voltage of the coin cell battery on the back side of this. So it's running off of a coin cell battery. Again, really great for your application on a remote device. You can tell when the battery is being discharged, or you could hook up a energy harvester to run the device. All right, let's show the single standalone board. So now it's been reflashed to measure the internal temperature sensor. The programming jumper is off now. I just leave it attached in case it has to get reflashed. Programming header is off. It's not going to use the meander pattern. It could certainly use both and transmit both readings, but I'll use only one. Nice convenient board because now I can flip it over and just put in a battery. So it'll auto start. Let's see if I can do this one-handed. You know what? Let me pause it and put the battery in. There we go. Battery is in. So now I've installed the battery. It auto starts. Go back to my software here. and start my heart rate. Again, it'll show up as a, and actually that battery, I'll try to clean it up, this fairly cheap battery, sometimes you got to rotate it around to really get the thing to connect, and then it should auto start. There we go. Just have to rotate the battery around a little bit. Sometimes if to insert it and take it out, I'll try to clean up those contacts on that. But then it auto starts, and again it shows up as a temperature sensor node on the app. So I go ahead and select it. Legacy is fine. And it will start a transmit again once every second. This one's a little bit higher. I was playing around with the hairdryer, so may have not recovered yet. And it has not been completely calibrated, so it should be 25 degrees C, should be 25 on the reading, but you'll notice that it does go up as you do heat it up. So that's about it. Any other questions, let me know.